All right, thank you again, everyone, for joining this morning's workshop on data visualization with Python, Cloudian fundamentals. So this is the first workshop. I'm going to be giving a follow-up workshop next week, which is a little more advanced. This morning, we're primarily going to be focusing on using matplotlib, which is one of the most widely used graphing libraries in Python. And we'll also be touching a little bit on using pandas and Seaborn to make graphics with Python as well. So I've made the materials available in this GitHub repository. You can launch into an interactive environment. For those of you who can authenticate with UCLA, there's a link here to launch into the Jupyter Hub that I've set up with the Institute for Digital Research and Education. For those of you who don't want to launch into that environment, there's another one here which will launch you into a similar Jupyter environment, which is publicly accessible to anyone. So I'm going to click on this to show you what happens. You'll get to an authentication page where you click on the orange button, and then it will ask you to select an identity provider. If you select UCLA, it will take you to the Shibboleth login page, and you can log in with your UCLA credentials. You're also welcome to choose Google as the identity provider. If you choose Google, you have to choose your g.ucla.edu email account in order to be allowed to use the Jupyter Hub. Then it will start up your environment. You'll see a scrolling blue bar, and then this particular link will clone files from the GitHub repository into your directory that's sitting on the Jupyter Hub. So that went by kind of quick, but there was a little blue scrolling bar. That's just files being transferred onto the Jupyter Hub. And now when you're launched into this environment, you have your own isolated environment where you can modify these files as you wish. And if you log out and log back in again, your files will be saved in the state they were when you made the changes. Let me pause here and ask if anybody's had any trouble accessing the Jupyter Hub or clicking on the links. Okay, good. So in order to interact with the notebooks, all that you have to do, so in response to the chat question, if you're not affiliated with UCLA, on the GitHub page, there's a link, a button called Launch Binder. If you click on the button to launch Binder, that will launch you into something that looks very similar to this. And you interact with it in the same way that I'm showing here. That Launch Binder link might take, a minute or so to spin up, but that'll be the same environment. These two files that have the IPYNB suffix, if you're not familiar with the Jupyter interface, I'm not going to go over a lot with Jupyter, but Jupyter is an environment where you can interactively program in a variety of different languages. In this case, we're going to be interactively programming in these notebooks with Python. And the first thing I'd like you to do if you're interacting with this is to open the matplotlib.ipynb folder just by clicking on the file name. When you click on the file name, it'll open up a separate tab in your browser. And then you should see something which looks like this. So in this case, I'll scroll down here just a little bit. So there are a variety of menu options at the top, which if I click on these, you'll see this is kind of reminiscent of a word processing program. So there are a number of kind of things you can do with a notebook through these menus. All we're going to be worrying about today is just typing in programming cells and executing cells in order to execute the commands. So when I click on something like this, there's a bounding bar that's around this, which this is called the cell. And in order to execute the commands that are inside of this cell, you hit Shift and Return or Shift and Enter. In this case, nothing is output because all it's doing is importing libraries. Another way to run a cell, you can click on the run button. Here, there's a little red button icon, or you can come up to the cell menu and say run cells. So what I've typed in here are Python commands. Anything that has this kind of grayish background to it is considered a code cell. There are also other parts of this notebook which are just text. So when I clicked on this, you see now there's a bounding box around this. This is also a cell, but it's a cell that's just rendered as HTML. So one of the convenient things about these notebooks is it's like a computational narrative where you can combine narrative elements like this along with coding elements like this that you can execute inside of the notebook. I think that's all the setup that I need, but if you have any questions about interacting with this interface as we go along, feel free to mention it to me. So now to dive into the data visualization. By far, I think one of the most commonly used libraries for plotting and data visualization in Python is Matplotlib. So Matplotlib, this comes from its website, is a comprehensive library for creating static, animated, and interactive visualizations in Python. And it's intended to make easy things easy and hard things possible. So as we'll get to in just a second, there's kind of a higher level submodule, which it's easy to write commands to generate initial graphics, but then it's also possible to access things on a much lower level where you can really tweak individual things inside of the figure. So the easy things easy is the high level kind of submodule that we interact with. The hard things possible means that there are a lot of things that you can tweak with the graphics with this library. And Matplotlib offers you a very kind of low level way of altering graphics. So it was built on NumPy and the SciPy frameworks. These are numerical computing libraries in Python. And it was initially made to enable interactive MATLAB-like plotting, which is where it gets the name Matplotlib. So actually, it did gain some early traction with support from the Space Telescope Institute in JPL. So that's just over here in Pasadena. It's easily one of the go-to libraries for academic publishing libraries because of the low-level control that you have, and it gives you very powerful options for customizing the figures. In addition, Matplotlib underlies the plotting capabilities of other libraries. So when we talk about pandas and seaborn later, Matplotlib underlies those libraries and it can actually be used to tweak the graphics that you create with these libraries too. Let me make my text a little smaller so you can see this. So this is a graphic kind of showing the low-level things that you can do with the Matplotlib library. So when you generate a graphic, say you're generating the curve and you want to plot the dependence of an independent variable, you might plot something. You know, when we think of plotting a mathematical relation, we kind of focus conceptually on the curve that it generates. But in terms of the graphic itself, there are a lot of things about this plot that's generated which you can tweak. And so there's some ambiguity, for example, in the axis limits, you know, the little ticks that mark what your major and minor axes are, kind of what your labels are, the title, what you want in the legend, whether or not you want a grid, the colors and the widths of the lines. All of those things are objects that you can alter with a Matplotlib library individually, in addition to just generating the graphic, you know, that shows whatever it is that you want to visualize inside of the figure. This graphic itself was generated with matplotlib. So along the way of what we're going to be working through, we'll actually generate some parts of this, and I'll show you the code later for this, which hopefully, after we go through our workshop, you'll be able to understand how you can generate this exact graphic with matplotlib. But at the beginning, we're going to start a little more simply. So the first thing that we need to do, which I've already done actually by executing this cell, you'll want to execute the cell if you haven't already. This cell imports the libraries that we need. We're going to be using the NumPy library just to generate some data to plot. So I import the NumPy library and I give it the alias NP. NP is going to refer to NumPy. I import matplotlib, a specific submodule of that library called pyplot. So pyplot is the submodule which is intended to make the easy things easy. So pyplot is a submodule which you can kind of call with very simple methods to generate a couple simple graphics that you don't want to kind of alter a lot before you just generate the graphic. This is a standard convention in matplotlib, is to import matplotlib.pyplot as PLT. So when you look at code that's using matplotlib, PLT is one of the common things that you'll see. And then this is kind of a Python magic command that's used a lot in when you're doing interactive graphics. This tells it to generate the output right beneath the cell that you're executing the code with. So first a couple of things about how this is going to be output in the Jupyter Notebook, along with kind of showing you a very simple plotting example. So plt.plot, this calls the plot method from the plt submodule. And to that, I pass in just a list of numbers, 1, 2, 3, 4. So this is the Python list. It's passed as a parameter into the plot. And when I run the cell, it generates a graphic for me. What it generates is a line plot. In this particular case, you can't see the individual points that are being used, but if you don't pass in both X and Y values, it will assume that it's just going to plot this based on what the index is in the list. So Python indexes start at 0, it goes 0, 1, 2, 3, and then it plots the points 1, 2, 3, 4. So 1, 2, 3, and 4. And then it draws a line through those points. The other thing you'll see that it generates is this. This is kind of an artifact of the fact that we're executing this inside of the Jupyter Notebook. In this case, what this prints out is the particular thing, kind of the thing that this is, which is it's a line 2D object. We aren't going to really worry about these particular objects per se, because I don't want to get too deep into the Python at the expense of the graphing. But there are ways that you can generate these plots without showing explicitly that this object is available for you to interact with. One thing, if you execute the next cell, this is exactly the same command, but I put a semicolon at the end. In this case, the semicolon tells it not to output the particular object that's generated, so you don't see that line. Alternatively, you can come down here to this cell, plt.show. The show is just a method to show the graphic that's been generated. And since the show itself isn't one of the matplotlib objects, you don't see that object line. So I may jump back and forth between the plt.show and the semicolon, but kind of those are two ways to show the graphics within these Jupyter Notebooks. All right, now on to more of what plot is doing. So if I do specify, say X and Y values, the convention is that the X is listed first and the y is listed second. By x and y, I mean the horizontal and the vertical. So when I execute this cell, now it doesn't start the indexing at 0, it starts it at whatever the first element is of this list. And then it uses this for the vertical value. So we're going 1, 2, 3, 4, 1, 2, 3, 4, and 2, 4, 6, 8. So this is just a line with a slope of 2. In addition to passing in your elements, you can pass in things which alter the graphic itself. So here, this is kind of a bluish line, which is connecting the points that I pass in as the data. If in addition to passing in the points, you can specify, say, what the color is. So I'm going to change this to a greenish color. Let me stop my email so we don't get that ping. I'm going to change the marker so it shows, in this case, this is the character that represents making the points circles. It's just a lowercase o. And then the line style I've set as nothing in between the quotes. So this will turn off the line feature. So when I execute this, now you can see how passing in these parameters to plot, kind of a simple way to tweak the way that the data is represented inside of the graphic. So it made them into green circles and turned off the line. You know, oftentimes the data that you want to visualize isn't this simple. So we're going to get a little more complicated. I'm going to say that the x is going to be a NumPy array. This, if you aren't very familiar with NumPy, don't worry about it a lot. Hopefully some of this will be relatively straightforward. np.linspace just generates an array of values, which are going to get assigned to x, which go from a minimum of 0.5 to a max of 3.5. And there are going to be 10 points in the array. And then the y values are going to also be an array. It's going to be an array that has values which are cosine of x for each of the points in the x array. So when I run that cell, I'm just going to show you here what's inside of these. X has 10 points from 0.5 to 3.5, and then y is cosine of each of those points in the x array. So when we plot those, we should see something that's kind of like a cosine curve. You know, it's not a cosine over the full period of the cosine wave, but it has that feature of the cosine, goes from 0.5 to 3.5. And you'll see, so again, it's using the default plot behavior, which is just connecting the points with a line. In this case, you can see it's not really a smooth curve because we only have 10 points in here. And you can kind of see some places where it has the kinks. A shortcut to passing in parameters, which makes it a little bit easier to generate these graphics at first, is simply to pass in the character string. In this case, the first letter is the color, the second letter is the particular character that you want to be for the markers, for the data points. And then I haven't specified anything for the line style, so it assumes that I don't want anything for the line style. So this is the designation. B is for blue, 0 is for circle, and it generates blue circles for each of the data points in the arrays. Yes, actually, so in the next cell, there's a question in the chat, is there a comprehensive guide about the aesthetic changes? So let me execute this next cell. All that this is showing you is, well, I'm kind of going to tell you about something else first. In addition to passing parameters into the actual plot method, passing in those parameters change the aesthetic elements that are kind of representations of the points that you're plotting. there are other things on the graphic besides the representation of the data. Say one of which in this case is the Y label. So there are other methods that you can call in the PLT submodule. In this case, I'm calling the Y label function, and I'm specifying the particular character string that I want to be for the Y label. You'll see up here, there are no labels. Matplotlib doesn't try and put on any kind of label by default, just assumes that there isn't anything. So I specify the label here and it puts the character string. So here, if you go to this link, this now is taking you to documentation for the Matplotlib library, and specifically for this plot. Remember, this matplotlib.pyplot was our PLT alias, so plt.plot is what's represented here. If you, there's a fair amount to read here if you want. If you scroll down to the bottom, it tells you here, you have color marker and line. These are the designations for markers. So 0, or the O here is for the circle. These are for different line styles. So you can have like a solid line or a dotted line. And then let's see, where are the colors? Oh, here they are. So the colors, here's blue, here's green, and these are kind of the basic colors. There are more sophisticated ways actually to specify the colors, which we might get to a little bit later. But these are the colors that you can specify right in the plot as a parameter. We'll get in a little bit to kind of playing around with some of these parameters. I'd like to set up a couple more things first. And so we'll get to some more exercises in just a little bit. I'm going to generate some new data. This is over the same range from 0.5 to 3.5 with 10 points. And then this is just another cosine function. In this case, it's going to generate, well, let me plot it, and so you can see what it does. It's possible to put more than one line on this simply by calling plot multiple times. So in this cell, this is what I showed up here, where you plot X versus Y as blue circles. If I call plot again, it's going to take exactly the same graphic. Oops. And on top of that, on top of this graphic, it's going to plot X2 versus Y2. K is the symbol for black, S is for squares. So this is going to generate X2 and Y2 as your data as black squares. It's still going to have the Y label as cosine. But here you can see, you can plot multiple things on just a single graphic by calling plot 2 times in this case. It is actually possible to just call them back to back. So you might also come across simple cases which are written like this, where this is the specification for the first set of data. This is the specification for the second set of data that's on the plot. When I execute that, it's the same thing. There's a question to split them into 2 different graphs, would you just call plot.show twice? I don't think that that's going to work. Let me see what happens when we do this. Indeed, it does. We'll get to a better way than this to generate 2 graphics. But yes, indeed, it does look like this generates the 2 different graphics. So yes, this is a nice and easy way to generate two different graphics side by side. For the moment, I'm going to change this from being represented by markers to just represented by lines. So here I only specified B for blue, K for black, and by default, it's going to join the points by lines. So here you can kind of see more clearly the cosine behavior for these points, kind of the longer period sinusoidal function for this one. With PLT, it's very easy to just continuously modify different elements of the graphic it is that you're interacting with just by calling PLT dot and then additional things it is that you want to change. So for example, this is the same as what I've used for this graphic, but now I'm including an additional PLT function called xLabel, which is going to give it a label on the x-axis. So here, this is X now, this is Y. You know, you can continuously build on these. So when you see kind of a graphic that's been generated, say for a publication, there might be a lot of things to sort through, but a lot of them are kind of have something which is very simple like this for actually generating the curve. And then a lot of additional commands which tweak different elements of the graphic it is that you're looking at. So here I've tweaked the Y label and the X label even a little bit more. I've given it a different font size. You know, so in addition to passing in additional parameters to the plot, you can pass in additional parameters to other methods that you call. And now I'm also giving it a title, say cosines. Right, so now you can kind of see we're starting to build on this graphic, well, not build on the graphic per se, but just tweak different elements of the graphic, which make it more kind of visually appealing and conveying the information that we want it to convey. And then I'm going to do one more thing here. So this now is the same as what was used for this, but instead of show, it will just executing this cell is still going to show the graphic inside of the notebook. But you might also appreciate knowing this method. So this is the method that you call to save the graphic that you're generating in a file. So you can call a savefig, and then here I'm just passing in the name of the file that I want to be saved. So when I execute this, it generates the graphic. But if you come back up to your browser tabs and you look in if you go back to the one where you see your folder hierarchy, you'll see now there's a file called cosines.png. If I click on this just to open it, you'll see the same graphic that I generated inside of the notebook. And if, just to orient you, if you ever want to download or upload files to the Jupyter Hub environment, you can click on this little red box icon next to file names. That will give you an option to download it. As long as it's not a running notebook, you can download it. You can't download folders like this is a folder, but you can download individual files. If you want to upload anything to interact with other data, say that you have, you can come over here to the upload button in the upper right. And when you click on that, it will open up, you know, a prompt to select what file it is you want to upload. But for example, I could click on this and download the cosines graphic, and then open that up in a separate window on my computer. There's a question, how do you save the figure in other formats? I don't think you can probably save it as an Adobe Illustrator format. I'm not sure about PDF actually, but let me hide my video controls here and show you the, this is the documentation for Savefig. I'll just post this here in the chat window if you actually want to look at it yourself. These are the different parameters that you can pass into Savefig. there are a variety of different things that you can tweak here. I haven't tried actually to save it in something like a PDF format either. But, you know, one of my recommendations actually, if you think that there's something that you want to do with Matplotlib and you don't quite know how to do it, open up a Google search, type in Matplotlib, and then type in just a couple keywords of something that you want to do, you know, and there are very highly likely odds that you'll be able to find somebody who, you know, right off the bat will show you exactly how to do it. Oh yeah, thank you, Mark, for posting that link to the class materials. Yeah, so and someone else in the chat said after cosines, just put in cosines.pdf. Let's see. So here we've generated, oh, well, it's blocking me from trying to look at it. But if I download this, I'm only sharing my web browser screen, so you probably won't see this. But if I'm opening this up on my computer, and indeed it does save it as the PDF. So it looks, in this case, you can just save it with the alternative suffix, and that will generate the PDF. All right, so I think we've gotten to a good place now where we can start doing an exercise. The first thing I'm going to show you is something which gets a little closer to the this anatomy of a figure that I showed up at the top. You might recognize this actually from what it is that I've been plotting. This is that cosine function that I was plotting, except it shifted up along the vertical axis. I'm going to show you how to put in a couple different things for that plot. So in this cell, I'm using as my x values 100 points from 0 to 2 pi. And then I have two different curves that I'm going to be plotting, y1 and y2. I have two different calls to plot, which will generate the two curves that here. And I'm going to let you play around with this in the next cell. So I've specified a color or line style and a line with both of the curves. I've specified what the y limit is. So this is the designation for changing the range on the vertical axis that goes from 0 to 4.5. This is the method that you would call to specify the particular ticks along the axis. So here you pass in a list of values for every point where you want there to be the tick. Here I've specified the X label, the Y label, the title, and you can even add in text on top of the figure. This puts it as an X and Y value of 3 and 0. This is the lower left-hand corner of the text, and then added text is what it adds. And then annotate will allow you to put in something like this, which will allow you to put in text and then put in a little arrow too, which will allow you to kind of put in text as well as some kind of arrow in order to really draw the viewer's attention to a particular point of the graphic. So in this particular case, the text is spine. The particular point that it's pointing to is 6.28, which is 2 pi, and 1.5 in the vertical direction. This is the X and Y value for the text. The text itself is bold and blue. The arrow itself has a style to it and is blue as well, and then it shows the graphic. So hopefully this is starting to become a little self-evident, even though I'm probably throwing a lot of things about PLT at you. But this is taking this data that you want to plot, plotting it, and then altering a lot of different features about the graphic. So in this one, I've written down a description of some things that I'd like you to try. You're welcome to try other things if you want. This is kind of an exploratory space where maybe I'll give you 5 minutes here just to play around with this, and you can ask me questions if you run into trouble. But I've put in commented lines, for things to alter about the graphic. And feel free to go back up to that reference if you need, or look at the matplotlib documentation to try and play around with this a little bit. So I'll let you play around with that, and I'll come back here in a couple minutes. Yes, to the question, is there a way to add text outside of the plotting area? I think if you specify the rest of you can play around with this. I'll just show this to Peter or anybody else who wants to pay attention. I think if you specify this just not naturally at some point that's outside of the it's not going to show it because it's actually outside of the figure. One way to do this is to specify what's called an artist. So maybe hold off on that question a little bit until I show you the actual code for the anatomy of a figure, and then I'll show you how they generate the text that's outside of the graphic. Tick marks to the top of the plot is a good one that I don't know the answer to. You might have to consult the documentation for that one. Yeah, so for the question, can I explain a little bit more about NP? NP is up here. NP represents the NumPy module. So NP, NumPy is actually a very sophisticated library, but NumPy is intended to kind of first and foremost provide I think a way to represent arrays and matrices for numerical computing in Python. When I say import NumPy as NP, NP is the alias for NumPy, and then NP has a variety of different methods that you can call, such as this. So when I call here np.linspace, linspace say is a function that's written inside of the numerical library called NumPy, and then I'm passing in a variety of parameters to the linspace function. And what's generated by that is what's called a NumPy array. That's why this is output as array and not just a list. So NumPy has objects which are called specifically NumPy arrays. Kind of underneath the hood, it's written in a very much more efficient way than you might normally program with Python. So often it's written, NumPy has, say, functions which underneath the hood are written in C and Fortran, which are very, very efficient when you want to do numerical computing. In addition to having kind of the array generating capabilities, that has a variety of mathematical functions which allow you to do numerical computing with NumPy. So something like cos is the specification for taking the cosine of a particular value or a NumPy object, like the NumPy array here. And then the NumPy, let's see, if you want to get started with it, this is probably not useful. If you're actually interested in NumPy itself, one of my previous workshops, I talked more specifically about working with NumPy and with SciPy. So NumPy and SciPy go hand in hand. SciPy kind of has a much larger list of functions that you can use to do numerical computing with the NumPy arrays that you generate with NumPy. Let's see if this is. To read in data to be displayed, do you mean that you want to use different data in the plot function? To some extent, it depends on what file format the data is in. So we'll come to this a little bit later. Let's see where I have this. So there are a variety of different ways that you can import data. So I'm going to jump ahead just a little bit here just to show you this. ASCII data. ASCII data, you just have to open a file and then kind of read it line by line, or read the entire text of the file into a variable, and then you kind of have to massage the data so that it knows, say, what's X and what's Y. Let me see if I have. Sorry, this is just taking a little while to open. Oh, that's unfortunate. So unfortunately, it doesn't seem like my browser is being responsive. It might be because I'm both on. So let's say we have text like this. So in this case, this is just a comma separated value file, a CSV, where say I have column titles and I have indices, and then I have values in here. One way to interact with this is working with a library called Pandas. This is probably the easiest way to import the Pandas separated values. So, oh, I'm sorry, that's probably because my internet is a little spotty at the moment. Let's see if I can change this. Let's see, is it coming through any more clearly now? Maybe not. Oh, okay. Thank you. So the easiest way to import the CSV is to use the Pandas library, which here I've designated as PD. This is Pandas. We'll get to this a little bit later, but it has a very convenient function called read_CSV, which will read a particular CSV file into a variable. So in this is kind of fast forwarding a lot. But if I use Pandas and read in the CSV, this will put it into a nice, what's called a data frame format, where it's like a nice tabular format for the data that's represented inside of the CSV. If you don't say want to use Pandas, or you want to work with other files which aren't comma separated variable files, you can just use, you have to use more of Pandas file processing capabilities. So I would do something, say, like this, where I'm not sure if you're necessarily familiar with the with operation, but this will open the file and assign the file handle to the variable f. And then you would say, like, let's see if I can, so you would have to use something like, f.readlines will just read the entire file. So this is reading everything, including the commas and the new lines. and you kind of have to massage this yourself in order to assign it to the particular variables it is that you want to plot. I hope that answers your question about the text. Yeah, if it's just a singular column data, if it has a definite format to it, it might not be that hard to read in, but they're, kind of file importing is a little finicky depending on what it is that you want to do anyways. So it might be best if you have a particular case, I could talk with you after this where we could talk about how to import your particular data that is you want to use. There's a question, do the file path inputs follow Linux formatting? I'm not actually sure. I don't know if there's a difference between the character. I would imagine that there's a way to read in the character returns differently. It's say like, depending on whether you have the Mac returns or the Linux or Unix or the Windows ones. That might actually be another question to address later. Let's see, did anybody have any questions about the stuff that, let me go back to here. Did anybody have any particular questions about doing anything with this exercise? Or yeah, Robert, that's true. So I put in a cell here, which if you execute, this will load in the text from a file that I've included inside of the helpers folder. If you go to this helpers folder that I've included with your files, there are a variety here that I'm going to load in with some of these exercises. If you simply execute that cell, let me show you again what I did. So these ones with the %load, this is a Python magic command, which will load in the text into your cell from this particular file. So when I execute that, it loads in the text from that file. Now, when I execute this has my take on making all of the modifications that I put in for the comments. So when I generate that, here's the annotation for the green line, titles moved up. I changed the range. I made these dotted lines, all of that jazz. All right, we're going to go on a little bit of a sideways track now. So I mentioned that this is kind of the easy way to do easy things is to use PyPlot, which we've abbreviated as PLT. There's another thing you'll see when you, if you start interacting more with matplotlib, there's figure and axes. So in these graphics, figure refers to everything that's kind of in this space where the graphic is generated. And axes are different, is a way to refer to an object which handles all of these little elements which you build up to make the final graphic. I'm going to generate the data array here again. So X is an array from 0 to 2 pi. Y1 and Y2 are these particular, the set of data that is used to generate those curves. When I call plt.plot, now hopefully this is familiar, this generates the two different curves for X versus Y1 and X versus Y2. Now there's a little bit of a lower level way to specify that you want to generate the graphic. It still uses PLT, but here I'm using, I call the figure method. So plt.figure returns the figure object. By itself, that will kind of just be blank. But you'll have this object, which is sitting there waiting to have different graphic objects added to it. And then with Fig, I can add a plot to it. So you can generate multiple different sets of graphics and axes within the given figure. So I add a subplot here, but this is just for one plot. And the parameters that I pass into it, this is the number of rows, the number of columns, and within that number of rows and columns, the particular kind of index of the thing it is that I want to, where it is on that figure that I want to generate the graphic. And what this generates is an axes object, which is commonly abbreviated as AX. This ax, it's not an axis like the horizontal and vertical axes. The axes in matplotlib is kind of an entire object into itself, which is used to control different elements of the plot. This axes object itself has a method called plot. So if instead of plt.plot I call ax.plot, this has the same effect as calling plt.plot. And then I show the graphic. All it does is it shows the same graphic because I've done essentially the same thing. But now I'm interacting more closely with particular objects, which are used to generate these. PLT is a submodule which kind of sits above the objects and allows you to easily send things to these objects, but PLT is kind of at a higher level than Fig and Ax, the figure and axes objects. It's also possible to do fig.show. That has the same effect. The figure itself now, when we start accessing these lower level objects, we start having more control over the lower level things that are used to generate the graphics. So here I'm passing in the figure size. The fig size parameter controls what the size is of the graphic. And it doesn't matter whether you specify the commas or not, but you can specify this kind of list of, well, not list, but these parameters separated by commas. And now you can see that the graphic is bigger because I passed in the additional parameter for the figure size. Another common way that you'll run across this is that the figure object and the axes object won't necessarily be initialized on separate lines. They're commonly initialized together. So if you call plt.subplots, this particular method returns the figure and axes objects. So this is the Python object for Python syntax for assigning two returned objects to these particular variables. plt.subplots generates the objects, and this assigns the figure object to fig and the axes object to ax. Now here, the syntax is that you also specify the number of rows, the number of columns, and here I'm passing in the fig size parameter again. So it generates the same thing. The question came up before, how do you generate, is it possible with plt.show in different places to generate two plots? And the answer there was yes. This is another way to do it. So subplots, if I pass in 2, this will now be 2 rows and 1 column. And now axes objects, there's a separate axes object for the first row and first column, and another axes object for the second row and second column. But there's just one figure object. So now when I call a method that's a particular method of one of these axes objects, I have to index it because there are multiple axes objects. So the first one I index with 0, the second I index with 1. Now you can see that there are 2 rows, there's 1 column, and each of these has a separate curve. This one is x versus y1, this is x versus y2. So now I'm going to come back up to the code that I used kind of as our first exercise. This is what it was used when we used PLT when we use kind of the high level pie plot. So just to show you what this generates, this is what it generates. And now I've rewritten this. This is going to look very similar when we're working with the axes objects and the figure objects. If you execute this cell, it will load in what that code looks like if you use specifically the figure and the axes objects. So the code should look familiar, but this is where we generate the figure object with plt.figure. This is making the first plot. In this case, there's only one plot, so there's just one axes object. And aspect equals 1 just means that the aspect ratio kind of numerically is going to be equal to 1. So a scale of 1 horizontally is the same as a scale of 1 vertically. That's kind of an aside. But here, instead of plt.plot, I call ax.plot. Instead of plt.ylim, a lot of these with axes objects, you don't just call the method, you do something which sets the values for a particular element of the plot. So now instead of plt.ylim, this is ax.set_ylim. This sets the y range, this sets the x range. This now is the method for setting the y ticks. And I specify different parameters for the ticks. This is like the font size from before. I set the x ticks, I set the x label, I set the y label, I set the title, and then text and annotate are similar. So this generates the same plot. Probably the size is different because I specified now the fig size and the aspect, but otherwise it's the same. But now, this is the way that you start getting at the lower level control of the plot. There's actually quite a lot you can do with the lower level control of the plot. And I'm not, we just don't have enough time to go into all of the details. But I hope this gives you enough of an exposure to it that, the things that you run across, I think conceptually, mainly what it is that you'll be dealing with is the PLT for the high level, or the figure and the axes objects for the lower level. And then you have the plot, which actually generates the data on the graphic, and then various elements of the graphic that you tweak to make it how it is that you want to look. So if I look at anatomy of a figure, so here, this graphic, I'm going to make this smaller. This, as it says, was made with matplotlib.org. I'll paste this into the chat too if you want the web reference. So there are a number of new things that are going to be evident here, but the main structure is everything that I've shown you so far. This is importing the NumPy library, importing the high-level PyPlot submodule. This generates the graphics. So in addition to 2 cosine curves, this is just a random distribution of points, which is used to generate all of these points which are in between the 2 curves. This initializes the figure object. This initializes the axes objects. And then it does some more fancy things for setting the placement of ticks and the particular, ticks that are major and minor. If you want to look through these, you can look up the documentation for any of these. But this particular section is just generating the ticks. This sets different parameters about the ticks. This sets the X and Y range. This sets the style of the grid, which as it's highlighted here is, just the grid that's on top of the figure. The grid, these are the commands to plot. So here's X versus Y1. This is a new way to specify a color. This is for line width. This is the label that shows up in the legend. There's titles, X labels. This is for the legend. And then I mentioned artists very briefly before, but there are different things, PyPlot is only one submodule of the Matplotlib library. So there are other things for different effects, different things that you can draw on top of the graphic. There's this thing called a circle. The circle, so here you see axe.add artist circle. This adds this particular object on top of the graphic. So all of these little things here are called circles, which are added as what's called an artist on top of the graphic. And then this adds text on top of the graphic with a particular color. This is just alignment and the weight and the color. And then all of this is specifying all of those circles and text on top of the graphic. These are the two annotates. This puts this made with matplotlib.org in this particular corner, and then it shows the graphic. So within this, let's see here. The normal thing that we plot might be the curves, it might be the scatter point, but then you can add artists on top of it, you can add the text, you can add these annotates, you can change the range and the ticks and put in the legend. It doesn't take too long before you figure out how to start adding a whole range of things on top of this and kind of creating whatever data graphic it is that you want to generate. One thing that that I also wanted to show you is that there are a variety of things that you can do at the higher level, in addition to just making these scatter plots, which are kind of the markers. Remember before I just had plt.plot. Plot by default does the line. There are other methods within PLT, but besides just the plot, which are different ways of generating different graphics. So in addition to the plot, scatter will automatically give you kind of the markers for the data points. This is like a scatter plot. And with scatter, you can have multiple points all over the ranges. Bar will give you a bar plot. And then you can pass in different parameters to all of these calls to PLT as well. So width just sets the width of the bars inside of the bar plot. This is actually in the numerical, 0.2 and whatever this horizontal scale is. Bar H is for doing a horizontal bar plot. There are quite a lot of different ways to plot the data. Yeah, well, perhaps obviously so, but there are different kinds of fundamental plots that you can use to represent data. So bar plots, line plots, scatter plots. 2D data is also can be important to show. Now, this is the Python syntax for generating the array in X, the NumPy array in Y. And then this generates a 2D NumPy array with this function called meshGrid. So this is just a way of generating the two-dimensional NumPy array. And then F, this particular function, it's exponential in Y. It's like a Gaussian function in Y, and it's cosine in X. So this is plotting a contour plot, plt.contourf, and all that we pass into it is the function with those values. Not the function itself, but the actual values that are generated by this particular equation. There's a question in the chat, can you add data labels to the bars? I may have, you mean to these particular bars? Yes, you can. The way that's immediately coming to mind is just adding it as specifically text. So, you know, if instead of writing it like this, I wrote a function, I could write a function which adds text on top of the graphic at a particular place within the graphic. So like with the plt.text, that adds text at a particular place. And then I would just add the text at a particular, you know, point based on what the height of the bar was. That's kind of, that's one way, for example, to add text on top of the bars. There may be other ways as well. With this contour plot, you'll notice, just like with the regular plt.plot, if you don't specify what the x and the y scales are, it assumes that it's just going to give you what the index is for the element. So here I had, these were both 100 elements, which is why it goes from 0 to 100. Just as address a question in the chat, so it seems graph types are not in the Matplotlib website. Where can we have a comprehensive guide for graph types? That's a good question, and I don't know offhand, but what I would guess is if you look at the documentation for PLT, so someplace in, you know, you might have to go a little bit deeper into the documentation, but the documentation for PLT, I think this will work. If you haven't seen this before, this might be something which is, oops. So if you do __dir __, you'll see all of the different things that are inside of this particular module. You know, there's probably too many for me to look through to see where the different, here for example is contour, here's contour F. You know, somewhere, actually, oh, well, that doesn't help very much. If you dig into the documentation or kind of experiment with that, this particular dir, you know, and just look at the different options, you'll probably see, you'll get an idea of what different graphics can be generated inside of this. For example, this was for generating a histogram. This is 2D histogram. ImShow is one that you should look up if you're interested in image processing, or just in 2D graphics. ImShow is kind of a way to generate a 2D graphic. Let's see, what do I show? Well, I think the contour plot is the last one that I'm going to show for 2D graphics. I'll just show you here, when you specify X grid and Y grid as the first two parameters in contour F, now it realizes here what the appropriate scales are, depending on what you pass in. And then with any of these, you know, even though I'm calling PLT, you can always access the lower level objects if you want to, by calling PLT and then .gca. GCA is get current axes. So it gets the current axes object for this particular plot. And then I use those lower level axes object to set the x ticks. Here I've set them to 0, 2 pi, and 4 pi. And I've specified what the labels are. Here I've done something a little fancier where I'm specifying, you can specify the strings in a LaTeX-like format if you want to get something like the pi character. I want to be sure that I get to a little bit of pandas and Seaborn. So I'm going to show you these next two things and kind of skip over the exercises for the moment. This here is just to show you kind of how to make an array with different types of plots. So in addition to calling PLT dot, whatever type of underlying graphic it is that you want to generate, you can do the same thing with the axes object. Here, this generates the data. It's just random data in 2 dimensions with 100 points. This generates the figure in the axes objects. Now we have 2 rows and 2 columns. So with 2 rows and 2 columns, you have to pass in both the row and the column to the particular axes object that you're interacting with. And then this generates a histogram. This generates a scatter plot. This generates, just the default line plot, which connects all the different points. And this generates a 2D histogram, since you have, you can specify both dimensions for this. And then I encourage you to come back and play around with this later. So I've written some suggestions for how to play around with this. I'm going to skip over this for the moment, but if you execute this particular cell here, you'll see code which will do what I've suggested up here. So I won't, well, I'll just show you, you can execute this and it will load. It will load the file that I've included here. And then the final thing that I'll show inside of this notebook is to make 3D plots. 3D plots now, in this case, it's generated in a surface plot. So, it would be good probably for you just to look up the documentation for how to generate 3D plots if you're interested in 3D plots. But this generates the figure and the axes objects. This generates the particular data that's being plotted. And then ax.plotSurface is the method which will make the surface plot. So x and y specify the scales, z is the height. And then there's various things for the colors and for the limits on the z-axis. And then I have something here which you can play around with too, if you're interested later, as well as kind of a result for, in this case, I'll just show you the result of this. This is just making a surface plot. So up here, I showed you here's the contour plot. Here's the surface plot that you can generate. So I went through the end of this a little bit quickly, just in the interest of getting to the next notebook. But I'll pause here and ask if there are any questions before I head on over to Pandas and Seaborn. Okay. I'm going to close this notebook. And I'm going to open up, if you're following along, I'm going to open up this one called Pandas Seaborn. Pandas, if you're not familiar with it, is a very popular library for doing data science these days. So it's a really good software library for manipulating and analyzing data. Pandas comes from panel data analysis. And I think it originally came from someone with a financial background, but it's probably one of the most widely used tools for data munching. So you can easily import a variety of different file formats with Pandas. It gives you ways to present data in nice formats to filter data. And what we're going to be looking at is it gives you convenient functions for quickly plotting data. So Panda, as I mentioned before, was built on top of Matplotlib. Pandas kind of takes the initiative to some extent and gives you some nice features right up front that allow you to generate a graphic without necessarily having to play around a lot with features in order to get it to look pretty. These first ones, these first cells, I'm going to execute, but they're primarily set up. So if you don't understand them, that's okay. This is just initializing the environment. I'm going to be using a library called Yahoo_Fin, which gets stock information from the Yahoo Finance library. Requests gets information from an API. So the data I'm grabbing is from a publicly available API on the Yahoo Finance page. Pandas is often abbreviated as PD. And then I import Matplotlib and IPy widgets I'll show at the very end. This is a library for doing interactive graphics. And then this function I've just set up so that I can have a function where I can pass in a stock ticker symbol, and it will give me the name of the company that's represented by that stock ticker. So in this case, AAPL is the stock ticker symbol for Apple. SI.getData just gets financial data, in this case about Apple. And it passes it into a variable called few days. So hopefully this doesn't seem like too much setup, but it is only setup, and we'll get to the data visualization shortly. But with pandas, you have series and data frames are kind of like the fundamental data objects in pandas. Pandas data frames are these tables. So they have rows and they have columns. The rows can have an index. In this case, it's indexed by the date. So these are values for the Apple stock starting from January 2020 and going to March 31st, 2021. Kind of the open value, high and low value, and closed value for each of these dates. So we have tabular data now. If we wanted to use something like Matplotlib to plot the data that was inside of this table, this kind of might be the Matplotlib way to plot it. But I'll execute the cell. This shows you the time series history of the high values for Apple stock over this particular date range. So this is kind of abbreviated Matplotlib, but it calls plt.subplots with one row and one column. Since there's only one plot, it sets the fig size, and then it returns the figure in the axes objects. Then I use the axes object to plot the data. Few days.index, the index are the dates. Few days.high is a way to reference the high column inside of the data frame. And then I use set title to set the title. Get symbol AAPL just returns the character string, which is Apple Inc. And then this is a method that you can call on the figure object. If I didn't have that, the dates would just be printed horizontally. So that's, the strings are long enough that that's not necessarily the most convenient thing to look at. So I just did the auto format xdate to set it kind of at a nice little tilt to make it easier to visualize. Pandas generates a graph which is like this just by calling plot on the data frame itself. So the data frame itself is this pandas object, which itself has methods. One of the methods is plot. this will generate the graphic. And then I specify that I want Y to be this particular column from the data. So that the name of the column is high. And when I execute this, it generates the graphic where it's assumed that I want to use the index of the data frame, which here are the dates as the horizontal axis. So now with pandas, I'm not necessarily interacting with the matplotlib submodule or figure and axes objects. I'm only doing this purely with the method that's inside of, that's a part of the data frame object. This module then has different things that I can call, which are reminiscent of the different elements of the graphic that I could modify individually with a matplotlib module or objects. So here I call fewdays.plot with, this is the column that I want to plot. And then fig size is one of the parameters. The title is one of the parameters. Legend, I say I don't want it to be there, so I set that to false. This now generates the graphic, which is similar to what I could do with matplotlib. But it's starting to be a little easier to do this because I'm not necessarily going in and tweaking each little individual thing about this. I'm setting the values of some parameters that I put into the call to the plot method. Data frames also have other methods just besides, well, the plot itself has other methods. For those of you who were paying attention before, this is the pandas way to read in data from a CSV into a data frame. This is just a convenient way to give us some data to work with. So this is the data frame. These are all companies that are on the Dow Jones Industrial Average. These are investment companies which hold this percentage of the company. And then this was something I included when I was talking before. But this is the data frame itself. I called it Apple Top 6 because these 6 companies are top holders of the company, of investments in the company. This is the data frame, and I call plot, and then I call dot bar. So this will generate a bar plot. There's a lot of data here, so it all gets scrunched together, unfortunately. But you can see, if you look sideways, these are all the companies. This is the index for the data frame. Well, it's not the index. Here I've specifically specified the column it is that I want to be on the x-axis. And then for each of these rows, which represent a different company, it has a bar for each of the other columns. So for all of the six investment companies, it has a different bar representing their investment in this particular company. So now let's say we want to take this and we want to tweak it, so we get a little more information out than just getting a blast of the entire thing. This command is just a way to sort values of a particular column and to orient the other rows to match. So this sorts the values for the Vanguard group. This goes from low now to high. When I plot this, right, sort values returns the data frame itself. On that data frame, which is this thing, I can call .plot.bar to generate the bar plot. I say I want the x-axis still to be company, and now I'm going to specify other parameters like fig size, and this is for a color map. So now I made it a bigger plot so that these are spaced out a little more. But the Vanguard group is the red bars, which you can see are continually increasing And you can get a little better picture of how the other investment groups, vary with their holdings as well. But we probably want to go into a little more detail on this if we want to zoom in on the plot, say. So I can choose, in this case, I'm going to look at the top 5 that the Vanguard holds. So instead of going from low to high, ascending equals false just orients it from high to low. And then this takes the top 5, and I assign it to Vanguard top 5 as the variable. This in turn is a new data frame. So since it's a data frame, it also has the plot method. And now I'm calling bar H instead of bar. So it plots it as a horizontal bar plot. Just like plot and the axes objects had a variety of different data plotting types that you could specify. Plot with the data frames has a variety of different methods that you can specify here as well. So this now gives you a zoomed in view of the top 5 holdings of the Vanguard group, as well as the particular percentage holdings from the other members that I've included in the data frame. And you can see now you can get a better view of what the names are for the companies here. So just to take a little break from me talking and to give you something to try, you can take these pandas plots that are generated and then alter elements of them using actually the matplotlib commands that I was showing you before. So for example, you can use plt.gca to get the current axes objects from the pandas plots. And then you can use matplotlib methods to alter the plots. So just as an invitation for you to try something out, try changing the horizontal axis here from 0 to 15, and try making the axes 0, or the x ticks 0, 5, 10, and 15. What does just mean? So this is just a specification for, there are a whole range of default color maps that are available inside of pandas and inside of matplotlib. So I think if you look up, let's see actually if this is color maps. I'm not sure which one of these might show it best. But you'll see, for example, if you look up any of these color maps, here's just rainbow. I don't know if the text is too small on mine, but this just rainbow here will give you this particular color map for the values. It is indeed possible to import a data set from online, yes. You just have to, you have to figure out a way to get it either into your particular set of files that you're plotting, so that the command that you call is accessing a particular file. For example, you could use like wget or curl to grab data from online, or if there's an API that you can interact with, you can use the whatever function it is in the API that will access the online data. I'm going to grab some water, but I'll be back in just a minute. right, so I'll come back now and show you what my particular take on this was. So here, this grabs the current axes from the plot and assigns it to the axes object AX. This sets the X limits to 0 and 15, and this sets the X ticks to 0, 5, 10, and 15. And when I execute that, you'll see 0, 5, 10, and 15. And now the legend is out of the way of the bars too. So despite the fact that we generated this graphic with methods from pandas, we can still use matplotlib to tweak other elements of this if we want a little finer control over the graphic that it's generated. And now for Seaborn. So Seaborn kind of has the motto, if matplotlib tries to make easy things easy and hard things possible, Seaborn tries to make a well-defined set of hard things easy too. And it's particularly good with statistical graphics. So Seaborn, I've included a couple notes here about it. It's built on top of matplotlib, which I mentioned before, and it's closely integrated with the pandas data structures. So the pandas data frames, which I was using above, are very well integrated with the Seaborn library. Seaborn is used a lot for statistical graphics. And even if you decide not to use Seaborn, Seaborn does have some default settings as far as changing the characteristics of all of the plots that you generate. So some of those style settings, if you decide that you like them, it might be useful just to use the style settings, even if you don't use the underlying Seaborn library. So I'll show that to you, what that means in a second. So I import Seaborn and I give it the alias SNS. SNS is the Seaborn library. And now I'm going to generate a couple different plots just to show you its capabilities. We don't have a lot of time left, and there's a lot that you can do with all of these libraries. So I do encourage you to look up examples of Seaborn if some of this looks interesting. So we can generate a scatter plot. Instead of plt.scatter, we call sns.scatterplot. And now this shows the integration with the pandas data frame. So data is a parameter to scatterplot. This is the data frame for Apple Top 6. Just to remind you, Apple Top 6 was this big one with the company and then with columns for each of the investment companies. So here, now I say I just want a scatter plot. I want to look at how the investments of BlackRock and Vanguard Group kind of how they scale with each other. So this is a very, I'm not specifying a lot here in my call to scatter plot, but you'll see Seaborn now does take the initiative as far as labeling what the axes are. It kind of, it may not be super evident, but it does kind of have a nicer little aesthetic here just out of the box than matplotlib does. This kind of shows you, there are very similar investments between BlackRock and Vanguard Group. There's kind of not a strict linear relationship, but there is kind of a linear relationship here. We can get an even better idea of what the relationship is by calling lmplot. We call it with exactly the same parameters, and this generates a linear regression curve, as well as a band here as to what the uncertainty is, or I guess the deviation of the points about this particular line. This gives you a feeling for some of the focus on statistical graphics that Seaborn brings to this. Seaborn can be used to generate pair plots. So I don't want to include the company name itself necessarily in the pair plot, but I just want to look at how the investments of each of the investment companies look when you plot them together as a scatter plot. The pair plot will generate a large grid where you plot each of the companies against each of the other companies, and then along the diagonal it plots the histogram of the values for a particular company. So it's without a whole lot of work, we're starting to get a lot more information out of some of these statistical graphics, which might take us a lot more work to generate, just say with Matplotlib itself. To give you a sense of what I mean with the plot stylings, I'm going to switch over to a little easier data set to grasp. This is the iris data set. So looking at 3 different species of irises. This is a data set that's kind of commonly used as just an example data set for data science or for machine learning. This plots 4 different parameters of each of the different flowers for this sepal length, sepal width, petal length, and petal width. And I'm going to do something here where I set the style. I'm going to set the style to be white grid. So you can look up the documentation. There are a variety of different styles that you can have. This sets some of the default aesthetic features of the plots. When I call scatter plot, I called scatter plot above, but now I'm passing in the petal length versus the petal width for the scatter plots. And I'm specifying a different parameter called style, which gives you different styles for the markers depending on what the values are for particular species. So if you're working with categorical data and you want to plot, say you want to plot all of the data itself on the same plot, but you want to plot the categories as different styles to see if there's an easy way to differentiate between the different categories. Seaborn starts to give you a very easy way to do some of these visual comparisons with not a whole lot of effort into what it is you put into the plotting parameters. I mentioned white grids, so perhaps this escaped your notice just when trying to comprehend the data, but I put in the legend, it put in the markers in this particular species, it gave a title to the legend, it put in the grid, it added the different X and Y labels. Say I use a different style setting called dark. These style settings are ways to kind of change some of the default aesthetics just so that it's easy for you to tweak some basic things about the plots without a whole lot of effort. Dark grid would probably just include the grid as well as the particular way to visualize the color. One thing about setting these styles with Seaborn is that it will change the styles even if you don't use Seaborn to generate the graphic. So if I come back up here, say to this particular one that I generated with pandas, now this is plotted with a dark background and the light grid. And even for just a plain plot with Matplotlib, like this one, it will change the default aesthetic of the plot that's generated with Matplotlib. So if you decide that some of these style settings, you think are particularly nice for your use, you could use Seaborn just to set the style settings. And then it will apply to other figures that you generate with Matplotlib or pandas as well. We'll come back down here. So in addition to setting the marker style, I'm going to change this to white. Hue will allow you to assign a different color to the data points. You can also generate, here I'm going to generate a pair plot for this particular data frame and use hue to differentiate the data points for different species. Now it's not plotting a histogram along the diagonal, it's plotting the density plot for each species. But you can see with Seaborn, it's kind of much easier than Matplotlib and Pandas to start generating something that's very aesthetically pleasing to look at. And that's definitely one of its advantages. Kind of from another standpoint, it's easy to generate graphics like this, where you start to generate graphics from which you can draw information about, say, one particular column that has different values in it, which are like categorical data. So that's kind of evident in this particular cell. So with a facet grid, now I'm not just generating one graphic, I'm kind of generating 3 different graphics where all I've done to specify this is just said that I want to split the data into columns based on what their value for this species column is. This just sets the color based on what species is. This is the data frame. And then for this particular object, which is generated by scatter grid, this is how I want to generate the plot. So this is Matplotlib syntax, PLT. PLT.scatter will give you the scatter plot, and this is the horizontal and vertical axes. So really with Seaborn, it starts to be easy to generate information like this, where you can draw out features of categorical variables if you want. And then regplot, this will just generate the regression plot for the data. So I'm coming to the end here. I've touched on some of the main libraries that you might want to work with. Just as a preview of what we'll be talking about next week, there are some libraries which are very powerful for having interactive features. So some Python libraries are built with something like JavaScript embedded into them. So Plotly, these last couple cells, are just intended for you to execute to see some cool features. Plotly uses some JavaScript, so it ends up looking like a Seaborn plot to some extent. But now if you drag your mouse, you can select particular regions, say where it will zoom in. One of these will be like a hand. Actually, I don't remember how to do that. But this has interactivity built into it. So you can zoom in, you can zoom out, you can pan across things. You'll see when I move my mouse over a particular data point, there's a box coming up telling me what the value of the variable is. You can do this in 3D, which is really snazzy. So you can zoom in and zoom out. I'm doing on my mouse kind of a zoom in and zoom out thing with my fingers on the trackpad. Or I can hold the cursor down and move this all around. And then to show you something with not necessarily a graphics library, but something that adds interactivity on top of what you might generate with Matplotlib. This particular function is equivalent to what we use to generate the graphic up here. So this code is essentially what's in the code of this function down here. But now I'm going to generate it so that we can look at all of the stocks and Dow Jones Industrial Average and just select which one we want to look at with a little menu. So this is the time history, and if now we have a little menu where we can come and select the stock ticker symbol of any of the stocks on the Dow Jones Industrial Average and look at how they varied over the past year. So we'll be talking a little bit more about some of these other libraries which build in the interactivity, or actually that allow you to program in interactivity into the plots, as well as ways that you can use other libraries to work with graphics that you've generated, to interact with the graphics. And that interactivity can be used and for a couple of different purposes, which we'll talk about next week too. And kind of as a final note, I'll also advertise that on Wednesday of next week, if you're interested in making geographic plots, like something related to GIS, my friend and colleague Yo will be teaching a workshop next Wednesday, which I encourage you to go to as well. And he'll be talking about doing the geoplots with pandas. So I'll stop here, and if you have any questions, I'm happy to stay around and answer them. I'm going to stop the recording now as well.